Hi, Nishith.
Hello, thanks for
Hello.
having me.
Of course, I hope my screen is visible.
Yep, I can see it.
Okay, perfect. Uh, what good agent identity looks like, and we have with us Nishith Sinha from Databricks. He's recently joined Databricks. He's also ex-Amazonian, or how do you call, ex-Amazon employee. And yeah, and wonderful having you over here, Nishith. And as you can see, I don't know if you joined the panel in the last 1 hour, everyone was talking about identity. So, this session is pretty key to talk about identity. We have only one session on identity, so let's talk about it. And would love to have some introduction from you.
Awesome. Yeah. Can I share my screen?
You can share your screen. Just give me a moment. I'm trying to figure out how. So stop sharing. Now, maybe I can allow you to try to share.
All right. Okay, perfect. Thank you, everyone. I am Nishith. I'm a senior manager at Databricks. I lead the AI security and red team functions at Databricks. Um, I previously, like Ankita mentioned, was at Amazon, couple of leadership roles in Gen AI security at Amazon, as well as AWS. I have 8 patents in AI security in areas such as identity-aware access control and secure model artifact storage. I'm active on LinkedIn. Please connect with me there. Would love to hear from you. All right, so what are we going to cover today? So our focus of our presentation is going to be what is agent identity, just so that we have a good shared understanding of it. Then we will talk about why agent identity is hard. Then based on that, we will get into what good agent identity looks like. And then finally, we go into future work and open research questions because agent identity is not a solved problem. So what are things that we need to do so that we get to a state where this is solved? So what is agent identity? A good way to think about this is it's the digital passport for an AI system, verifying who the agent is and whose authority it's acting under. We'll break this down into two crucial components, the agent's own unique identity and the user's identity, the human or the system the agent represents. This concept is often called blended identity. So, understanding and securing both of these identities is vital because it directly enables secure API access, ensures that every action is accountable and auditable, and ultimately prevents the AI agent from carrying out something which is unauthorized or malicious. In this slide, we will talk about how secure blended identity actually works, right? What's the workflow? So the flow starts with step one. The human authenticates and grants scope permissions to the agent. Think of it similar to an OAuth consent flow, but defined scopes, things like read email or write calendar. In step two, the agent presents both the human delegated credential and its own machine identity when calling the downstream service. The agent identity could be something like an MTLS certificate, maybe a signed JWT token, which lets the receiving service verify which agent is acting and apply the agent-specific policies. This could be things like rate limiting, audit logging, or restricting certain tools. In step three, before the action is permitted, both the human and the agent identity is verified. And finally, if step three succeeds, step four allows data to be returned or an action to be performed. So this two-layer identity model is becoming very common in agentic systems today. Next, we talk about a real-world example of blended identity. On the left, let's say you're building a system without blended identity. What you would see is anyone who has access to call the agent has full access to the database and the agent that the agent has access to. So there's no audit trail of who requested what access. On the right-hand side, blended identity ensures that you are getting data only for the authorized users. And in this case, it's John Smith. In addition, you get logging, which becomes super easy because you're propagating both the agent and user identity in the tool call chain. So we've established what blended identity is, but in reality, the systems we have today are not ready for agent identity. The core problem is that agents operate autonomously, requiring a level of trust, precision, and context that traditional human-centric identity systems simply were not designed for. So let's talk through the first three challenges in this area. The first challenge is dynamic delegation. So unlike a human logging in once, the agents operate in a complex tool chain, often delegating to sub-agents. This delegation happens on the fly, and we lack robust mechanisms to verify the chain of agents which your blended identity was passed on to. So now you're in a situation where you called a downstream agent, but you don't know what that agent called further downstream. And guess what? This problem becomes even more challenging when you're talking about 3P agents that you don't have control over in your enterprise system. Challenge two is context preservation. So the original user context and the user intent must be securely and accurately persisted across the subsequent tool calls. For example, if a user is asking an agent to summarize a sales report, a failure to carry the summarized context through the intermediary tool calls could cause the agent to accidentally delete the sales report. And we see many agentic prompt injection attacks today that leverage this gap. The third is granular permissions. So we have OAuth scope, and that has worked for the non-agent world so far, and it's worked well. But it's not granular enough. We need to move beyond the simple access, no access control. So an agent might need to read my email, but explicitly not read the financial data in my email system. And there's no way today that OAuth credentials will be able to give you this level of access. So our permission models currently are struggle to define and enforce this level of fine-grained intent-aware authorization, especially for fluid agentic workflows. Continuing our discussion on challenges, let's now focus on issues that arise after the agent is operational. A big challenge is auditability versus privacy. So I think even in the last session, we all heard how important auditability is. We need detailed logs that capture every action for accountability and to verify the chain of authority. However, those audit logs inherently contain sensitive user information. Right? So it could contain request responses, may even contain OAuth credentials that you're passing on to your downstream agents. And so the challenge is deciding who accesses the audit trails, for how long, while complying with the data protection policies. And this is a big challenge in the observability world that's now coming about, especially in more sensitive countries and geographic areas where data privacy laws are stricter. This is becoming a big challenge. Challenge 5 is agent impersonation. So malicious actors can clone, modify, or spoof legitimate AI agents. The fundamental challenge is preventing a malicious agent from successfully pretending to be a legitimate one. Digital signatures are a good approach here and provide the technical proof of origin, but they don't solve the broader integrity challenge in a multi-agent system. For instance, a human may delegate their identity to a digitally signed authenticated agent, but once the delegation occurs, the human has limited control over how the agent propagates its identity to downstream systems. And then finally, challenge 6 of cross-domain identity. Our agents interact with a wide range of services, right? Think of it as email, Slack, calendar, internal databases, each having their own authentication method and their own specific vendors. There's no standardization, which means there's no universal mechanism for agent identity federation across these different platforms. Think of it in your traditional pre-AI world, right? We all said like SSO is super important and we need to have that in place because we don't want you to have different credentials for different systems. And we solve that problem. We need to solve that exact same problem for AI agents because they need access to tools. And those tools have different identity stores that we need to talk to. So this makes it difficult to maintain a consistent, verifiable identity for agents across all the services it needs access to. All right, so agent identity is hard. The traditional identity systems assumed that a human is present and is authenticating all the time. But agents operate autonomously, and that's the fundamental mismatch that we have. So I want to run maybe a batch job of multiple agents that need to run overnight on my developer desktop. For example, um, I I will not be around at midnight approving those OAuth flows, um, which the traditional systems now require. And so our systems are not kind of designed for this autonomous flow that agents bring in. All right, so based on the 6 challenges that we discussed, here are 4 design principles that good agent identity systems must have. The first is dual identity verification. This is the foundation of blended identities, which means the system must always verify 2 things. One, the agent's unique machine identity, and 2, the delegated authority of the human user. Neither the agent nor the user's delegated credential should be able to act alone. The second is contextual authorization, which means the principle moves beyond static can access permissions. We need permissions that are intent aware and time bound, right? So for example, an agent can be authorized to summarize emails for 30 minutes, but explicitly not be authorized to delete emails, addressing the challenge of granular permissions. Third is auditability by default. To ensure accountability in complex delegation chains, every single action the agent takes must generate an immutable log that clearly attributes who the authorized action and who authorized the action and who executed it. So both the user identity and the agent identity needs to be part of the auditability logs. And this is getting increasingly important for post-incident analysis and regulatory compliance needs. And incident response is not just for security incident response. It's also for why did the action that the agent take at a particular point of time? Why was it X and not Y? And those things are becoming increasingly challenging because we don't have auditability baked into our systems today. And the last principle is secure delegation. So delegation must be cryptographically verifiable to ensure integrity. Systems should be able to prove the chain of agents that had access to the human credentials. And also the users must be able to revoke authority if the provided credentials um, were provided to an agent that it no longer trusts. So this moves us away from the ambient authority that we give to our agents today and forces explicit auditable grants for every action that's provided. So what does good agent identity enable? The question is like, why do we even need this? I think for users, it provides confidence that the agents act with fine-grained permissions and intent, and the user identity was not shared with downstream agents that I don't trust. For developers, it provides a paved path. You're not inventing and reinventing authentication for systems that you own every few months because there was a new security incident that happened. And for platform providers, it enables building trust with their customers and being able to efficiently run forensics in case of a security incident. And just like earlier, security incident is part of the whole incident gambit that you have with agent. There are also operational events. And even for those, like the identity angle becomes very, very important. So here's an example of a good approach for agent identity. And I'll walk through the diagram on the right where the user authenticates, provides its credentials. The user authorizes the agent and says, hey, this email bot can read my emails for summarization. The word summarization is important here because that's the intent that the user is giving to the agent. So the system is intent aware. And the agent authenticates, saying, hey, I am email bot with, here's my certificate. So classical MTLS authorization on top of the user authorization. And the agent presents the combined identity in step 4. So the email bot certificate, along with the credentials of the human, and with explicit intent and scope defined. Of here's what I'm trying to do. And that's validated. And the API, both the identities are validated and the scope. And if the authorization goes through, then only Alice's emails are returned to this user. And we have explicit audit logs, which mention who logged in, did what, both the human identity as well as the bot identity or the agent identity, and then also the intent or the purpose of summarization. So this makes it super easy for you to figure out if there is an incident on who did what and why. So explainability becomes super easy. So, so as many of you know, agent identity is not a solved problem. So you may ask, but why? Nishith, you just provided us 4 design principles. Let's go build systems that follow those 4 design principles. And I think the core reason for agent identity being hard, just like many other security challenges, is the security versus usability trade-offs. Things like when we update an agent, at what point is it a fundamentally different agent? and needs a new identity? It's a hard question, like based on the risk tolerance that you have in your enterprise. The answers would vary. Or for static auth style scopes, they aren't enough. How do we actually implement an intent-based authorization system with meaningful latency? I a lot of teams that a lot of security leaders that I talk to want to go to intent-based authorization, but it's hard, especially across multiple tool chains. Like making sure that the intent is actually captured efficiently and the latency requirements that we have for these multi-agent systems is shrinking every day. And so, how do you balance the latency requirements versus the need to have intent-based authorization? These are hard trade-offs with no clean answers yet, and that's the reason why in like agent identity is hard today. So looking ahead, we've got a few approaches that are worth keeping an eye out for. First is verifiable credentials for agents. So agents could carry uh, cryptographically signed credentials that attest to their capabilities, their creators, and the authorized scope, verifiable by any party without necessarily calling home to the credential issuer. Second is blockchain-based agent registries, having a decentralized tamper-proof ledger where agent identities are registered, updated, and revoked, giving us all a shared source of truth. And a third approach that I find particularly fascinating is the behavioral biometrics for AI agents. Just like we fingerprint human users by how they type or move a mouse, we can profile agents by their API call patterns, timing, and decision sequences. If an agent starts behaving outside its baseline, then that's a signal that something's wrong, even if the credentials are technically valid. So I'll leave you with this final thought on why agent identity is a foundation that we must get right. Um, thank you for your time, and I think we can open up for a few questions.
Okay. Hi, everyone. Nishith, amazing presentation. I'm just going to ask people to start with the questions. We have one. So, what trade-offs arise between cryptographic delegation chains and operational scalability in high throughput agentic systems? I think you can see in Q&A from Jatin.
Maybe I don't have the question. Could you repeat that again, please, Ankita?
Okay, yeah, just going to type it in chat also. This is a little bit longish question. So it's in Q&A. What trade-offs arise between cryptographic delegation chains and operational scalability in high throughput agentic systems, and how would you mitigate them?
Yeah, I think um, the fundamental challenge that you have is maybe I'll add there two. One is the latency requirements. It's shrinking every day. And so, yes, you can have a crypto verification step at every step of the delegation chain. But now you will have a latency that you will add on top of it, especially with multi-agent systems today, that becomes cost prohibitive very soon. Um, and I think the second challenge is when you have mixed systems or mixed agents, right? You have 1P as well as 3P. You sometimes don't have the ability to have cryptographic delegation in parts of the chain where you don't own the agents. You're calling a 3P agent, and maybe they don't provide that capability. And there's no standards today, which makes it super hard for you to implement something, especially with 3P agents in the chain.
Got it. The another question is from Michael Alexander. Which aspects of these do you feel are the most challenging to implement?
And I find intent-based authorization to be particularly challenging. And I've spent a lot of time on this topic. And there's just not a great way in which it can be implemented with the tools and technologies we have today. So you could argue like, hey, I get the intent from the user at runtime, but then the intent is not something that you would trust because it's untrusted input. Like that could be manipulated. And so that approach clearly doesn't work. Then you have the other approach of, hey, maybe I get the intent from the query that's come in or from the request that's come into the LLM. And arguably you would use like an LLM for that. And we know that is prone to prompt injection attacks. So it's a particularly hard problem where we don't even have a great starting point on how we even start building something around identity which starts at trust.
Got it. Another question is the presented blended identity in use already, or is it more of a concept at this point?
It is in use. A lot of providers, including us at Databricks, provide this blended identity concept. Amazon, um, Microsoft, like a lot of providers provide this blended identity concept.
Got it. So, question from me, do you think it will become mainstream since Databricks, Amazon, lots of providers are giving the identity, blended identity solution? Uh, for any agent builder app, we had Glean CISO just a few minutes, 30 minutes back, or Glean or Foundry, etc. What do you think about those?
I think so. Yeah, I think it's already kind of mainstream, at least in the big tech companies. You especially for things like Glean, right? You want authorization based on the user and not just the agent. And those systems you need to have a blended identity concept. So if it's not already mainstream, it'll become mainstream very quickly.
Awesome. Another question is there are lots of questions for you, Nishit. So we'll take maybe 5 more minutes for this. In the approaches you presented, how will we collect or bind blended identity to data, which is PII or PHI? And the second question is about federating blended identities. I think maybe you can take the first one. Yeah.
Yeah, it's an interesting concept, and I think Microsoft has a solution for this, um, where they're looking at a DLP solution bolted on top of agent observability. Um, and so they have a concept of Agent 365, where basically what they're saying is they're also looking at the blended identity plus the data that the agent is accessing and applying DLP permissions on top of the user identity in the blended identity to make a decision of whether the data access should be allowed or not. So again, like a few vendors are starting this. This is at the cutting edge of um, AI security plus identity. So very few vendors have started moving in this direction, but it's likely going to be something where again it becomes mainstream in the next 6 to 12 months.
Yeah, it's a very hard problem to solve also. I can talk from a vendor perspective, just agent identity, and you're talking about then data access and matching it with, all kind of PII and PHI. All this is because it's so agentic systems are continuously changing, and the way they access data, everything, all of that is so run in runtime and continuously changing across organization as well. It's a very hard problem to solve. So uh, in the panel also we discussed this is critical to have AI security, which is agent identity and what access you're having. But it's not a solved problem. There is a lot to be done here.
Totally.
Last question I think we can take is I have a this somebody is asked on Q&A. I have an MCP server tool which calls external SaaS using OAuth, but we have configured that tool in our Copilot agent. What would be the better approach?
So that's it's more like threat modeling on the fly. Um, I think it starts with trust. You're calling a third party MCP tool. We all know like how risky that can be. So first thing is just trust, right? Do you really trust that MCP provider? Um, the if the answer is yes, then maybe you should think about like, is that an open source MCP server? And if that is, then instead of calling a vendor API, like can you build that MCP server in-house? It's just like container images, nothing different, right? You can get a container image from the outside, or you can build it in-house. If you build it in-house, your SaaS tools, or these days cloud security, will have access to it. And if there are security issues, like you will find it and you can fix it or talk to the vendor and get it fixed. So, so think about again, MCP servers is untrusted, and the same approach that you would have applied to container images, just follow the same approaches here.
Wonderful. Nishit, no, thank you. I think there are lots more questions, but we don't have time. Thank you so much, Nishit. This is a very critical topic, I'll say. Not everyone, has this much knowledge about the topic that you do. And so thank you for sharing your thoughts. Thank you for initiating that conversation, very critical conversation to have in 2026. So thank you. Thank you so much. And I know I'm going to see you again in a panel.
Yeah, thank you. Appreciate it. Again, if you have questions, please connect with me on LinkedIn as well. Happy to
Yeah.
chat more.
Anyone who has question on identity, I'm sending you to Nishit for sure. He's the expert here. Thank you. Thanks, Nishit.
All right, bye.
Bye.